Hi, my name is Jamie Glaze, and I will be talking to you about the Higgs boson. Why is the Higgs boson so important? Well, it can explain how we come to exist. Now, the Higgs field, which is composed of Higgs boson, is a field that I would like to explain to you in two different ways. The first way is an analogy. If you can imagine being in a cocktail party and some famous person walks in. At first, you don't realize, nobody realizes that he's there, but after some time, people want to talk to him, so they start surrounding him. After a while, he starts gaining a large crowd, and that way, that person gains more mass in the same way that an electron would or a particle would. So, in a way, if it's kind of like saying that there's a Higgs field permeating all of space, and as particles move through that Higgs field, they acquire mass. So another way that I would like to show you is, imagine you have corn. These are your particles before the Higgs field is added. At first, they're kind of just loose. They kind of just move around. They don't really stick to anything. They don't stick to each other. Thus, they can build mass. And then you go in and you add the Higgs field, which is sugar in this case. You kind of just spread it around. That gives everything a mass. So it's kind of harder for them to move around. Each particle is attaches to the field in a different manner. Thus, that's why every particle, or some particles, have different masses from other particles. And that would be why, a photon doesn't have any mass, doesn't attach to the Higgs field at all, and it could just kind of escape the whole surface of the field. So that's another way of explaining the Higgs field. So that explains why, let's say, electrons have mass. Now, atoms, the radius of an atom is dependent on an electron, and electrons are dependent on Higgs boson. So in the end, atoms wouldn't exist without the Higgs boson. And if the Higgs boson wasn't there, then atoms wouldn't exist, and of course, we wouldn't exist. So the Higgs boson in the end tells us why the universe exists. Now, experiments have been done to try to find the Higgs boson, aka or the Higgs field, and on July 4th, 2012, they found a new particle resembling the Higgs boson in the Large Hadron Collider in Europe. Now, the way they did this, the way that they tried to find the Higgs field is by colliding subatomic particles and trying to find the Higgs boson, since they can't essentially find the Higgs field. A way to diagram why these collisions are important at all is a Feynman diagram. Richard Feynman was a genius. He kind of showed how a collision of, let's say, an anti-electron and an electron, when they collide, it makes a photon, and then after a while the photon decays, and that'll you'll end up with another anti-electron and an electron. Of course, the beginning entering mass and the ending mass is equal, but in this middle section you have a loss of mass, which is against everything we know, conservation of mass. So after some tests, a particle was found to gain the same amount of energy lost during this collision, and it was a SEB boson. And this pretty much just demonstrates an exchange of virtual particles. And in that same manner, physicists are trying to find Higgs boson by using the Large Hadron Collider. So this Large Hadron Collider is 27 kilometers around, and they made it that large because it takes a lot of energy to move, say, a proton at almost the speed of light just around a small radius. So it's easier to push something in a straight line. So at the same time, that's why the bigger the radius, the bigger the curvature you have. So you would need less energy to push the particle around that path. So one of the most important parts of the Large Hadron Collider is the atlas. It's the part of the Hadron Collider where the subatomic particles collide, and that's where it is measured to see what comes out. The particles measured will be graphed on what looks like an array of lines, like I have here. This is kind of like what the graph, or it is what the graph looks like, an array of lines. And each line represents some type of subatomic particle, and they will travel a certain distance and will either permeate this barrier or hit that barrier. For instance, right here, if you can see the yellow mark, that's the measurement of quarks. And over here, this area right here is solely for muons, because they believe that muons are very important in the discovery of Higgs boson. So it is very important for us to find the Higgs boson if we want to revolutionize physics, because it'll tell us why we exist. And I think they're coming a long way. I mean, they're every 15 nanoseconds they have about 12 to 40 protons colliding, and they were observing the types of subatomic particles coming out. So I hope you learned something today from my lecture. Thank you for your time.